In this session, we will discuss about the measures of dispersion. In the previous sessions, we have discussed about the measures of central tendency. For the measures of dispersion, we have listed out set of techniques which we can use to measure the dispersion or the variation. The degree which numerical data tend to spread about an average value is called the variation or the dispersion of data. It is quite simple if I explain it in this way. Suppose that if you are having a set of data, then if this is the mean value that you are having for the sample, then if a particular data point deviates from this x bar, suppose that if you are having x1 value here, then x2 may be here, then x3 may be here, then x4 may be here. Likewise, if you are considering x5, then we can find out what are these uh, values differ from the average value. But always we are not going to just measure the deviations from the average only. Apart from that, the generally we can say the degree which the numerical data tends to spread about the average is called as the variation or the dispersion of the data. When we are going to discuss about the measures of dispersion, here we will discuss about several types of measures that we can use to measure the variation of a given set of data. Under that, we will discuss about the range, interquartile range, which is abbreviated as IQR, then variance, standard deviation, coefficient of variation. Those things would be discussed under the measures of dispersion. Now we will look about actually why we need this, why we need to measure the dispersion. That is the purpose of measuring the dispersion. Then we can find out this as the main purposes of the measuring dispersion. Once we measure the dispersion, it will be able to test the reliability of an average. Then we can use these measures of dispersion as a basis for control of variabilities, because if we are using the measures of variability or measures of dispersion, first thing we can identify, have an idea about how the data is deviated from the average. Then if we need to have a control for this variability, first we need to identify what is the variability. Then if once we know about the variability, then we can have a mechanism to control the variability as well. Then if we are having more than or two or more than two series, then we can have the comparison of the variability as well using the measurements for dispersion of the variability. And once we know about, if you know about the central tendency, we just know about the location. We will be considered as the measures of location. But if you are measuring the dispersion, then we can use this as the mechanism which facilitates the basis for the further analysis. Suppose that if you just know about the mean value, then we can have a point value. But if you can find out a possible range for this value, it means that our mean value can be lies within this range. Then if you can find out, then to find out this range, what we need is we need the variability as well. Therefore, this can be considered as the purposes of measuring the dispersion. Then we will move for now discuss about the measures of dispersion one by one. The first thing is the first measurement of dispersion is supposed to be range. Then we can have the simplest measure of dispersion is range. Therefore, we can identify range as the easiest or the simplest measure of measure which we can use to measure the dispersion. The range of a data distribution depends upon the extreme items, but not on all the items. It is because simply the range is supposed to be the simplest measure that we can use to measure the dispersion. And thereafter, what we can say is, the if you need to find out the range, what we are using is we are using the largest value of the data set and the smallest value of the data set. Range is supposed to be the difference between the largest value and the smallest value of the data set. Then what we can say is, to measure the range, we are not going to use each and every value provided in the data set. Apart from using all the values, what we are using is we try to use the the extreme ends. It means that if you can find out the maximum value, if this is the largest data point that we can identify, and if this is the smallest or the minimum value that we can find out as the data point, then the difference between the largest or the maximum value and the smallest value, the minimum value, will be defined as the range. As an example, the data is provided for the 7 students. Their weights were measured 27, 30, 35, 36, 38, 40, and 43. Since it is given in the ordered way, we can easily identify that maximum or the largest value is 43, largest value is the value 43, and the smallest value is 27. Then we can find out the range of the provided data. We can obtain it as the largest minus the smallest value. Then 43 minus 27 gives the measure for the range. The difference between 43 and 27, it would be equal to 16. Therefore, the range of a data set for this data set would be equal to 16. Then we will discuss about the next one. It is the interquartile range. Interquartile range. Here in the word itself, it says that it is again measuring a range, but the range is measured as using the quartiles. That is why we are saying it as interquartile range, and which is abbreviated as IQR. Then we can say that interquartile range, or IQR, is a measure of statistical dispersion. IQR is a measure of statistical dispersion being equal to the difference between the third and the first quartiles. Here what we can use is we can measure the interquartile range using the quartiles that we are obtaining. Therefore, what we can do is to measure the IQR, what we are taking is the difference between the third quartile and the first quartile. Therefore, the equation that we can use to measure or to identify the IQR, we can use it as the Q3 minus Q1, where Q3 is the third quartile and Q1 is the first quartile. Here it is given a set of data, and you are asked to calculate the interquartile range for the provided data set. Therefore, what you have to do first is you can first find out the Q3 value. Q3 is supposed to be the third quartile, and thereafter you can calculate the Q1 value, which is supposed to be the first quartile, and then we can identify we can take the difference between Q3 and Q1 as the IQR of the data set, or interquartile range of the data set. If we discuss about this problem, here it gives us some details regarding the number of winnings and the frequency of such winnings. Then we can see that it is quite in the form of this ungrouped data. It is ungrouped data distribution. Here it is, we can say it is 0, the individual values, and its frequencies are used here. Then as the first thing what we can do is we can get the total number of values. It can be taken by taking the total frequency. Then value of n can be obtained as the summation of 3, 61, 132, then 153, 140, 51, and 3, which gets this value as 543. Here we can get the total value is equal to 543. But what we need to know now is we need to obtain the measures for Q1 and Q3. First, we need to find out the location of Q3. First, we need to find out location of Q3. Location of Q3 can be obtained as n plus 1 divided by 4. It is a location of Q1 I will take. Then we can take it as n plus 1 divided by 4. Then we can get it as 544 divided by 4. It is equal to 130. 136. Now we need to identify which would be the 136th element. Then to identify that, what we need to do is we need to construct the cumulative frequency for this provided data. Then if you are taking the cumulative frequencies, then we can construct the next row. I will continue it here. Then we can find out the cumulative frequency. It is now 3 here. Then added 61 to the 3. Then this would be 64. Then we have to add 132, altogether 196. Then we need to add 153 to this, which gives the value as 349. Then adding up 140, it is 489. Then plus 51, it is 540. Then plus 3, 543. Now these are the values that we are taking for the cumulative frequency, which is for this provided data set. Now we need to identify where this 136 belongs to. Now we can see that up to 64th item, it is belongs to the 0 and 1, but the items which are beyond 64 but less than 196 should be included as to this column. Therefore, the number of winnings will take as Q1, then this would be equal to 2. Then value of Q1 is equal to 2. Then we need to find out location of Q3 as well. Location of Q3, we can take it as the 3 times n plus 1 over 4, which we get as the 3 times this quantity. Then totally we had 543, then plus 1 divided by 4 gives the value as 408. It is exactly 3 times of 136, which we will get it as 408. Now we have to find out where this 408 locates. 408 is greater than 349 but less than 449. Then the value for Q3 would be 4. Then value for Q3 would be equal to 4. Now we need to find out the what we are saying as this IQR, interquartile range. IQR defined as the difference between the third quartile and the first quartile, which we can take as 4 minus 2 itself equals to value 2. Therefore, this is how we are calculating the interquartile range for the provided set of data. And suppose that if it is if we are having group data distribution, then in that situation what we can do is we can use the equations provided to calculate the quartiles. We can use the have the help of these equations. But anyhow, what you have to do is first is you need to identify the first and third quartile, and thereafter you can obtain their differences as well. Now we will discuss about the mean deviation, or which is supposed to be the average deviation. Here what we are going to discuss is what is mean deviation, and mean deviation is supposed to be the distance which the data point is deviated from the mean value. Here when we are measuring the distance, we are not going to check whether it is in the positive direction or whether it is in the negative direction. We will just get the magnitude of the deviation for a particular data point from the mean will be considered for the mean deviation. Therefore, first we are computing all these deviations, and then thereafter what we have to do is we have to get the mean value of those deviations. Since we are not considering about whether it is in positive direction or the negative direction, suppose that if we can have it in, suppose we are having mean value x bar is here, then if we are having x1 is here, then we just measure this distance only. We are not worrying about whether it is in positive or negative direction. Then this distance d1, Then D1 can be written as, here we just need the magnitude only, then we can take it as x1 minus x bar. Then next distance, if it is x2 is somewhat here, suppose that x2 is somewhat here, then we have to measure this distance which is given as d2. Then we can take the value of d2 which is equal to magnitude of x2 minus x bar. In the similar way, if x3 is here, then we can compute d3. We can compute d3. D3 can be considered, it is again the magnitude only, x3 minus x bar will be considered. Therefore, in this way we can compute the deviations, and thereafter what we have to do is we have to take the the average of the deviations. It is quite, if you had abbreviate this mean deviation, if it is individual data, it can be taken as the average of D1, D2. If there are a number of deviations, a number of data points, then it would be Dn divided by n. Then this can be represented using this magnitude notation, difference between the observation and the mean value. Then we can take this as the sigma magnitude of xi minus x bar divided by n. Therefore, if we are having individual data, what we are going to do is we are taking the absolute value of the difference and the mean value, then get the summation of such values, and then divide it by n, where n is the total number of observations. But if you are having group data, what we can do is we can take this mean value or mean deviation of x bar, then we can take it is the summation of fi times xi minus x bar over summation of fi. It is because the particular value, suppose that if there are 3 points in here, then there would be 3 points at x1. That is why we are multiplying this magnitude distance by fi and then divided by summation fi, where summation fi again gives us the total number of observation. Then these are the two methods that we use to obtain the mean deviation for the individual data, and the laterally mentioned equation for the group data. Now we will see how we can use this technique to calculate the mean deviation from the mean for this following set of data. Here I will do these examples one by one. Then we'll see what are the differences there. Okay, if I take the first one, take here. If I take the first example, it asks us to calculate the mean deviation for the data provided. Then if you write down the data points in this way, this is the value of x we are having. We do not have any frequency values. The values are 100, 150, 200, then 250, then thereafter 360, 250, 360, 490, 360, 490, then 500. Thereafter we are having 600 and 671. 600 and 671. To calculate the mean deviation, the first step is, as the step number one, we need to compute the value for x bar. Value of x bar can be taken as the summation of x over n. Then we need to take the summation of these values and divide it by n. Now we can see that if you get the summation of the data points provided, then the summation will be equal to 3321, and n is equal to 9, Altogether, we are getting the value for x bar is equal to 369. Now, what we need to do is we need to take the magnitude of the xi minus x bar. Then what we need to do is here we are getting the magnitude of the value which we are getting as the difference of 100 and 369. If you take the difference between 100 and 369, what we can see is we can take the difference is equal to minus 269, but since we are taking the magnitude only, we have to take this value as 269. In a similar way, the next difference would be to minus 219, then it would be just taken as 219 only, since we are taking the magnitude. Then next value would be 169. Then next would be 190. Then next one value would be 9. Then 419. It is with 490 value would be 121. Then the next value would be 131. Similar way, here it would be 231. Then the next value is 300. Now what we need to do is what we know is mean deviation is calculated using summation of modulus of xi minus x bar divided by n. Now we need to obtain the summation of modulus of xi minus x bar. It means that what we need to do is we need to obtain the summation of these data points, these values that we have obtained. That is the summation of 269 plus 219 plus 169 plus 119 plus 9 plus 121 plus 131 plus then 231 plus 302. Altogether we are getting this value as 1570. This is supposed to be the value that we are taking as summation of xi minus x bar. Then if you do the substitution here, we will get 1570. Then divide by n is supposed to be value as 9. Then if you are dividing this by 9 altogether, we are getting this value as 174.44. Accurate to two decimal places, we are getting this mean deviation as the 174.44. This is how we are use this for the ungrouped data. Then we'll discuss about the second example. In the second example, it is given as a group data distribution, but not with the class intervals, just as the frequencies and the point values. Then if you write down them as well, here we are having the values of x and the frequencies are given. X is going from 2, 4, 6, 8, 10. X values are 2, 4, 6, 8, 10. Frequencies are 1, 4, 6, 4, 1. Frequencies are 1, 4, 6, 4, and 1. Now what we need to do is, for as the first thing, we need to take the value for x bar. X bar can be obtained for a frequency group distribution. It is summation of fi times xi divided by summation of fi. We know we can simply get this value. Here we will get the summation of 1, 4, 6, 4, and 1. We'll get totally the value as 16, which is equal to summation of fi. Summation of fi is now equal to 16. Then we have to take the next one, it is fi times xi. Then we need to take the multiplication of these two columns. Then we'll get 2, 4 times 4, 16, 6 times 6, 36, 8 times 4, 32, then if you take the summation of the values, we'll get altogether this is equal to 96. Now summation of this is supposed to be summation of fi. This value is supposed to be summation of fi times xi. Altogether we are getting 96 divided by 16. We'll get this value is equal to 6. Therefore, we have find out the value for xi as well, x bar as well. Now we need to construct the next column. The next column is obtained as xi minus x bar. Here we will consider the magnitude of xi minus x bar. Then we'll get the difference of 2 and 6. 2 minus 6 we'll get as minus 4, but we are considering the magnitude only. Then we'll get this value as 6, value as 4. Then 4 and 6, the magnitude of the difference will be 2. 6 and 6, it will be 0. 8 and 6, difference it is 2. Then 10 and 6, again the magnitude of the difference will be 4. Here what we need to do is to obtain the mean deviation for group data. What we can do is we can use the equation. It is summation of fi times xi minus x bar over summation of fi. Now what we know is we know the value for summation of fi. It was obtained as 16, but still we have obtained the values for xi minus x bar, the magnitude of the differences only. Now we need to multiply these each value by the respective frequency value. Then we can get this next column as fi times modulus of xi minus x bar, then 1 times 4, 4 times 2, 6 times 0, 4 times 2, and 1 times 4. Then we need to take the summation of them as well. It is summation of 4, 8, 0, 8, and 4. Altogether we are getting the value as 24. Here we'll get this as summation of fi times xi minus x bar. Then we'll get this value is equal to 24. Divide by 16, we'll get this value as 1.5. Now we can find out the mean deviation is equal to 1.5. The next value, the third one, here it is provided the age in years. I will just say about how to solve this question, and you can try for it by yourselves. Here we need to find out the mean deviation for the provided data, but here we can see that the group frequency distribution, it includes the classes as well. Then if you see about this one, it's age, and we are having the frequency. Age is from 0 to 9. Then next one is 10 to 19, 20 to 29. These are the provided data. Then the frequencies, it is given as the number of persons. Then we can take them as the frequencies 25, 20, 32. 40, 42, 35 10. Here also we need to, it is again in the form of group data distribution, but age is given as the interval. Then as the first thing what we need to do is we need to obtain the midpoint of this classes. It is because it would be the generalized value that we can use for each class. Then we can take the mean values or this midpoint values, what we can take as mi value. This would be equal to, it is we have discussed how we can get the midpoint values. Here we'll get the value as 4.5. It is 14.5. Similar way we'll get 24.5, 34.5, like as 74.5. Now, using them, first we need to take the mean value x bar. Here we can have to take it as summation of fi times xi over summation of fi. Since we are not having a particular x value, it is given as a range, then this can be rewrite as summation of fi times mi over summation of fi, where mi is supposed to be the midpoint of the ith class. Then what we can do is we can now say this the equation for mean deviation. Then we can construct the next column. Instead of taking xi, now we have to replace it with mi, since it is the generalized value that we can consider for the xi. Then we have to construct this column, and thereafter we need to construct the next column. It is fi times modulus of mi minus x bar. Then mean deviation can be obtained by taking the summation of fi times, instead of xi, now we are using mi, since it is the class midpoint that we are considering, minus x bar, and divide by summation of fi. Using this equation, you can try for obtain the mean deviation for this exercise. Then we will move for the discussion of the next type of measure that we are use for measure the variation or the dispersion of data. But prior to discussion that, I will just discuss about the pros and cons of the mean deviation we are using here. Here this plus points, what we can say is it is simple to understand and easy to compute, and it is not much affected by the fluctuations of sampling, and based on all items of the series it gives the weight according to their size. It is these are the plus points that we can consider about the mean deviation. But the minuses or the negative points that we are saying, it is a non-algebraic treatment, as the algebraic positive and negative signs are ignored. Here we are not going to see about whether it is in the positive direction or negative direction. Here just we are measuring the number of units deviated from the mean value only. Then it is just a non-algebraic treatment. We are not going to think about whether the sign, whether it is positive or negative. Then this would not be a very accurate measure for dispersion, since we are not considering any algebraic dispersion of the observations from the mean value. And this mean deviation cannot be also used for the further mathematical or the statistical calculations. We can just take only this mean deviation, but it cannot be used for further calculation in statistics. So therefore these are the plus points and the minuses of the mean deviation. Then we will discuss about the variance and the standard deviation. These two measurements are supposed to be the most important and the most frequently using measures for the for measuring the dispersion of a given set of data. Here the variance and standard deviation will be discussed. Variance is supposed to be the expected value or the expectation of the square deviation of random variable from its mean. It is quite similar as the thing that we have previously discussed in what we are discussing under the mean deviation. What we had discussed was it is xi minus x bar only. But what we are doing is we are getting the expectation here, expectation in the sense we are getting the mean value there. But apart from getting the mean value, what we are doing here is we are finding out the expectation of the square deviation. It is quite like summation of xi minus x bar, then its squared term, it is the square deviation and its expectation, then we can get it as the summation, then divide it by n. Therefore this would be the simplest way that we can say we can use for calculating the variance of a data set. This is what I have explained now. Informally, it measures how far set of random numbers are spread out from their average. And this is what we are saying as the variance, and the square root of the variance is supposed to be the standard deviation for the provided data set. Here if you know the variance, we can take the square root of the variance as the standard deviation of the data set. And when we are going to discuss about the variance, again we have to define it for the population variance and the sample variance as well. Prior to discuss about the sample variance and standard deviation, first I will explain this part, and we will not going to make any calculation based on the population variance or the population standard deviation. We will just discuss about the calculation based on the samples what we are obtaining. Population variance, which is denoted as the sigma squared. Sigma squared can be obtained as summation of xi minus mu. Here mu is supposed to be the population mean. Then we are taking xi minus mu. Then the square terms will be considered and then get their summations and divide it by n, which is supposed to be the population variance, and it is for the individual data. But if you are having the group data, same as previous, each square deviation should be multiplied with the relevant frequency and then get the expectation summation of the set of values and divide it by n. This is how we are calculating population variance. This is for ungrouped data, and this equation can be used to obtain the population variance for grouped data. When I'm explaining the standard deviation, I told you that standard deviation is the square root of the variance. Then what we can say as the population standard deviation, which is denoted as sigma, it can be obtained by taking the square root of this entity. Then this sigma would be equal to square root of summation of xi minus mu square divided by n. And this is for the ungrouped data, and for the group data it would be same as this. It is because fi is the additional quantity we are using. It is because frequency has to be considered if we are obtaining this population standard deviation for the group data as well. Then we can get the population standard deviation sigma. It is equal to square root of summation fi times xi minus mu squared over n. But as for your knowledge, I have provided, but I am not going to discuss any calculations based on this population variance or the population standard deviation. Now we will move for the discussion of the sample variance and the sample standard deviation. Here the difference of the sample variance. Sample variance is obtained for the sample data we are using, and sample variance is this noted as s squared. Then s squared is obtained as summation of xi minus x bar squared. Previously we had the magnitude value, but now we are not going to consider their magnitudes. Now what we are going to do is we are just considering their square terms. Instead of magnitude, now we are taking the square term and then divide it by n minus 1. To make the sample variance as an unbiased estimator, that is why we are dividing this by n minus 1. If anyone interested, then you can you can refer to the videos or any explanations regards with the unbiased estimators. Therefore, using that concept, we can identify this quantity is not n, it would be n minus 1 for the sample data. Therefore, we can directly use this as s squared. It is for the sample variance. It can be obtained as summation of xi minus x bar squared divided by n minus 1. And if it is a group data set, then we can take this as summation fi times xi minus x bar squared is considered, then divide it by n minus 1, or we can take it as summation of fi minus 1, or simply we are writing it as n minus 1. This n is supposed to be summation of fi. N is supposed to be summation of f. Then to get the sample standard deviation, what we can consider is we can consider the square root of the quantity which appears here. Then we can take the square root of the sample variance as the sample standard deviation. Now we will see about the pros and cons of the sample variance and the standard deviation. The positive points or the plus points are it is rigidly defined and its value is always definite and based on all observations are used. Here to calculate the sample variance and sample standard deviation, all the values provided in the dataset will be used, and this would be rigidly defined technique, and the value that we are getting for the sample variance and sample standard deviation, it would be always a finite value. And the next plus point is it is used for the since the algebraic treatment is used there, then we can use these techniques or use the values obtained from sample variation or sample standard deviation for the further statistical calculations as well. And the sample variances and the sample standard deviation are less affected by the fluctuations of sampling. Therefore, we can say these are two stable measurements that we use, which we can use to measure the variability of a data set. Then the next one, it would be the negative points or the cons that we are considered for the sample variance and the standard deviation. It is more weight to extreme values because the values are scared. It is because if those are extreme values, it may be much more higher or much more lower compared to the other data points, then this value would be somewhat large. Since again we are considering its squared term, then it gets the much more weight here in the sample variance as well as in the sample standard deviation. And the next point is it is an absolute measure of variability. It cannot use for the purpose of comparison. Since we are taking the squared term, then we are not able to make much more easier in a way for comparing the data, whether it is in the plus direction or the minus direction. We can say is it is just the variability. We can just have it as variability high, this variability much higher than this one. We can just comment on that way only, but you cannot say that for the set A the variability is in a positive direction, but for set B it is in the negative direction. We cannot comment on that way. It is because we can just identify what is the variability, the magnitude of the variability only. And this is not that much favor with the economist or the any businessman. That is what I told previously as well. Since we cannot measure it in the positive or either it is in negative direction, this is not this is not that much in favor for the economist or the any businessman. It is because they are not able to find out the variability whether it is in positive or negative direction. But for the further statistical analysis, this would be much more helpful compared to the all other the techniques that we have discussed so far. Then here I have mentioned some exercises that we can refer for the uh, variance and standard deviation, and I will discuss these examples in the next session. And thank you all for your participation.